As David said, my name is Jason Lindsey. I'm a big science fan. I love to do science. Science is amazing. Science is something I've always loved since I was a kid. Now, here's the problem. In recent weeks, there's a evil little virus that's kind of changed the way that we teach science, and not only in schools, but everywhere. So many educators don't have students in front of them like they typically have in the past. For example, I stopped doing in-school assemblies as well as interacting hands-on with students back in March, and really have went more to a virtual approach. Lots of educators, about 1 million of them, will go to hookedonscience.org each week to download a free science guide, as well as get free videos and tons of free resources. Because from the start of Hooked on Science, I've done just that, approached it like a virtual aspect. But here's the problem. The majority of kids, and you as a teacher knows this, are not virtual learners. They are hands-on learners. They want the stuff in front of them. And we have to find a way to do just that. So I have this new science guide at hookedonscience.org, an at-home science guide that you can go download that gives you some of my tips to do just that. The experiments that we're going to do today include ingredients from around the house, and that's one of my tips. If you're going to do science at home, assign a student to master a specific next generation science standard. It's important that you make sure those kids can gather those ingredients from the kitchen, from the medicine cabinet, from the living room, wherever it might be. Very crucial that all of that stuff is there, because most kids, most moms and dads aren't going to have all of the wide ingredients that you might see for a hardcore science lab. So it's important that we tap into those resources that you have right there in the house at home. One other thing that I have found as I work with schools across America, and that is the majority of the families that are accessing virtual stuff are doing it on a phone. That's right, a small phone. And they are based on certain amounts of minutes that they have. Most parents, most families don't have a computer anymore. They're either using a device or, again, the phone to access this virtual stuff. So very important that you use those ingredients from around the house. I'm going to go over several experiments. We're going to create a bubble snake. I have all my ingredients under the table here. We are going to do the egg drop. We are going to jab pencils through a plastic bag, talk about matter. We're going to make some ping pong balls, float in the air, and talk about balanced, unbalanced forces. The main concepts we're going to hit here when it comes to next generation science standards would be 2nd and 5th grade, so that's matter, structure of matter, so on. We're going to hit some force and motion, so kindergarten as well as 3rd grade when it comes to pushes and pulls, and a few other concepts as well. But what I have in front of me, ingredients from around the house. So you'll notice I have kind of dissected a water bottle. I used some scissors to cut it in half. And then what I attached to it was a washcloth with a rubber band. And then over here in this, nothing fancy, no fancy bubble solution. I just have a copious amount of dish detergent and water. You're like, you're not giving me exact ingredients. I'm doing that on purpose, because the whole point of a student doing science is to use different variables, to try it different ways, to see what's best for them, what's going to work best for the outcome that you are requiring as a teacher there in your science guide or experiment lab or whatever it might be. So I might explore different things. What if I put 5 teaspoons of dishwashing liquid into a cup of water? Will I get the best result? What if I put 16 teaspoons? You get the point, different variables. But the outcome is pretty cool either way it goes. I'm going to take and dip this in here. Matter, anything that takes up space and has mass. It can exist in 5 states, but in elementary school, we mainly focus on the 3 main states: solid, liquid, gas. NGSS really focuses on matter made up of small pieces. The smallest unit of matter, as you know, an atom. And you're like, I don't have all this science background. I'm just an elementary teacher. Each science guide that I give you has all of that information on there. You don't have to be a hardcore science teacher with a science degree to do my stuff. I make it as simple as you can do. I know you don't have hours upon hours to plan. So I put everything on one sheet, all the step-by-step instructions, the connections to the next generation science standards, and the information you need when it comes to the science background of the experiment. So again, matter made up of small pieces. Typically, we use our 5 senses except for taste in science class to explore the matter. I want to put my finger in there, rub it together. Is it slippery? Is it not? Is there a lot of friction on my fingers? Describe the matter by its observable properties. Okay, so I'm going to go ahead and dip this in here like this, and we're about to create an amazing bubble snake. I did this on the Today Show not too long ago with a lady you may know, Kelly Clarkson. She loved it. Love doing it at home. And again, that's what parents are looking for in this virtual school, if you will, that we've all been forced into because of COVID-19, that's using everyday ingredients from around the house to get their kid excited about science. And you will notice my bubble snake forming. I'm going to go ahead and step out from behind the desk. I don't want to stay confined behind this desk, because I want to make sure that you can see this a little bit more. And you'll notice how we're creating this amazing, pretty cool bubble snake. Here's the science behind it. It's simple, folks. The wash rag, tiny little holes in it, make a lot of tiny little bubble wands. All those bubbles stick together, if you will, and you'll notice the bubble snake right there. You can change it up by adding food coloring on here, and then when you blow into it, the bubble will change colors. Again, using everyday ingredients from around the house, connecting it to next generation science standards, getting kids excited, affordable science, easy to understand. That experiment is probably one of the most downloaded science guides and most watched videos. I don't use YouTube on purpose because I feel it's bad for kids. As you know, not too long ago, YouTube was kind of caught tracking kids. They've stopped that by now without parents' permission. So I removed everything from YouTube. I use my own platform called Science on the Go. You don't have to worry about inappropriate videos popping up. You don't have to worry about any wacky advertisements. I do also use TeacherTube. I don't know if any of you teachers out there use TeacherTube or not, but I do use that as well. But Science on the Go is there. Every video, a different video and experiment is posted each week. This experiment, pretty cool. You'll find the guide there, as well as the connections to the next generation science standards, like matter for 2nd grade as well as 5th grade. Let me clear this up and we're going to go to our next one. Why don't we move to pushes and pulls, something that kindergartners and 3rd graders are learning, of course, as you go on up. Since I am doing something that might cause a projectile, I'm going to go ahead and do some science safety and put some goggles on. Inside of my cup here, I have a cup of toilet water. Okay, maybe not toilet water. Just regular water. Joking with you there. I work with too many kids. My dad humor and kid humor is coming out there. I need some other ingredients. You got a glass in the cabinet. You got water from the faucet. What else do you need for this? Oh, toilet paper too. Well, these were in big shortage not too long ago, but if you're one of those people who stocked up with gobs and gobs of toilet paper, you should have a lot of those around your house. Let's see. I need a real egg. You're like, a fake egg? Yeah, you can buy the fake eggs when it comes to your craft store. If you're working with kindergartners, I would suggest a fake egg. What I'm going to do next is put the pie pan on top. That you might find right there at your kitchen. That on top, and this on top of that. So I've got everything lined up here, and that's key. So a force is a push or a pull. Some things require more of a push or a pull than others. For example, it's all about mass, the second law of motion. Force equals mass times acceleration. Bottom line, more mass, more force. So if I had a school bus in neutral over here and a car in neutral over here, they had the same tires underneath. Which one would be more difficult to push? Well, it would be the school bus because it has more mass to it. With the same person, same strength applying it. So more mass, more force. So with all this going on here, here's my question to you. And that is, how do I get the egg in the glass without ever touching the egg? And the egg can't break, by the way. Anybody have a hypothesis? Okay. Apply a force, right? I'm going to do just that. Now, I work with a lot of kids. The smaller kids, you need to hold the cup at the bottom. Encourage parents to do that because they will sometimes knock the whole thing over until they get the hang of it. I'm going to apply a force. 3, 2, 1. What happens is simple. The egg resisted the change. We call that inertia, the tendency of an object to resist change. So I applied a force. The pie pan went that way, makes a unique sound. The toilet paper tube went that way. Then what happened next is pretty cool. Gravity took over. Gravity pulled the egg into my glass of water. Good thing it's not toilet water because I didn't want to put my hand in there. And the raw egg, not cooked, the raw egg is not broken. A cool experiment. I encourage kids to do it over the couch, right? Okay, maybe not. On the Today Show and even Fox and Friends, when we did a science experiment there, we did 5 glasses, 1 giant tray, 5 toilet paper tubes, and 5 real eggs. Hit it. Of course, 5 times bigger. It has more mass. Apply more of a force. And all 5 went in on live TV. Cross my fingers. Science doesn't always work that way sometimes, as you know, especially on live television. Okay, I better move to this next one before it starts leaking pretty bad. I have a bag of water, back to matter. Matter is made up of small pieces. Smallest unit of matter is an atom. Basically, what we're going to do is jab pencils through this bag of water. I have computers everywhere. We can't really risk the fact that it might ruin everything, can we? Oh, you know what I always tell kids, the bigger the mess, that means the more cool the science experiment. Okay, so I'm going to grab some pencils underneath here. It's important that you use the round pencils, okay? This bag made of small pieces, you're made of small pieces, I'm made of small pieces. Those small pieces will be holding hands, if you will, talking on a kid's level here, holding hands tightly around the pencil. It should still up. You know what? Let me get closer to the camera over here, and we'll do that right up here close so that you can really see this up close and personal. Okay, here we go. Uh-oh, there's a computer down there. Let me move back a little bit. We don't need a disaster. Okay, we're going to take that pencil and we're going to push it right through, all the way through, just like that. Notice it's not leaking out. Again, the science, it's simple. Basically, the small pieces that make up the bag, holding hands tight around the pencil. Push another one in. It's great to do this above the best behaved student in your class. Or maybe you can have the students do it above your head as the teacher. We're going to do another one. Uh-oh, we got a hole. Uh-oh, we got a big mess going on here. Welcome to science. And the cool part about it, I just clogged up that hole. Let me make sure there's no electronics down there. Okay, we're good. So we'll set this over here. That's a brave science experiment that you can try at home. It will make a mess. I would include or encourage parents to do that one specifically in the kitchen, because so many kitchens have turned into science labs across America. Okay, let's be honest, across the world, as kids cook up science experiments. Kids are naturally inquisitive. They want to do science. It's just us parents get in the way sometimes. I have 4 kids of my own. We're always doing science experiments, fixing holes in the wall because of potato launchers, repainting ceilings. You know, my kids can come to me and blame it on science and get by with it more than my wife, bottom line, because I allow them to explore, and that is so, so important. Let me monitor the time. It's about 2:54. Let's do one more experiment, and I think Dave will take some questions as we take it to the top there. I have a hair dryer. We are not fixing anyone's hair at all. What we're going to do is do a balance force. So when it comes to pushes and pulls, you know about balanced and unbalanced forces. Balanced force, it should balance on top. This ping pong ball that I'm about to pull out of my pocket. Unbalanced forces, it would not. So we're going to have air coming out of it. It will push up. Gravity should pull down. And wherever it balances out at is where you'll see it floating in the air. Now, depending on the holiday, depends on how I do this. If it is Halloween time, I will use a styrofoam pumpkin, floating pumpkins. So I kind of adapt it around what the holiday is or what kids are talking about. So for example, a lot of kids at one time were talking about Minecraft. So I, instead of banning Minecraft from all of my classes, I said, okay, let's develop a science project around it and engineer with Minecraft. So I turned classroom disruptions into learning opportunities. Same thing with Fortnite. We just did away with all the weapons in the kits, and the kids built creations of Fortnite, and we talked about the engineering design process and so on. So here we go. Ping pong ball, turn it on. That's a strong force. So let me go to more of a lower one. Put it right here. Make sure it's balancing, and there we go. So that was unbalanced forces. Now we have balanced forces acting on the ping pong ball. and it's floating right there in the air. Again, styrofoam pumpkins, so on, that you can use with that overall. If you're going to do this with little kids, make sure there's a cold button. That cold button is crucial, and the reason why it's crucial is because the hairdryer can get hot, and of course, kid safety, very important, as we all know, as we work with lots and lots and lots of kids. Now, again, as I'd mentioned, just to wrap up everything, as we are doing some pretty cool science experiments here, and that is, you will find all of my free stuff, experiment guides, videos at hookedonscience.org. I left television as a full-time meteorologist back in 2007 to do Hooked on Science. I'd go into classrooms and talk about weather, and kids really weren't getting hands-on science. So that's where I developed Hooked on Science. And I visit hundreds upon hundreds of schools, specifically before COVID-19. I think when I last counted, more than 1 million kids face-to-face, 1 million kids doing science and assemblies, classroom programs, family science nights, and so on. So I really do love working with kids and helping teachers find everyday items from around the house that teach next generation science concepts. I mean, hey, I know you have what, $1 million a year to spend on science supplies in each and every classroom? Not, right? You are looking for easy ways to teach science to make sure your kids can create a memorable experience. And we know that's 10 times better than circling on a multiple choice test. If we can create the all moment to where that kid will never forget that science experiment, those science words will sneak into their brain and it will be unforgettable. More kids come to me and say, hey, I remember the time you caught the table on fire. We talked about energy, and you told me that energy was the ability to do work. You told me that you can't create energy or destroy energy. Why? Because we sneaked in that memorable moment and it kind of burned it into their brain. That's the best way to get kids hooked on science. Let me monitor the time really fast. It's about 2:58 as we are nearing 3 o'clock, so my time is up. I wanted to see if you had any questions. I don't know if Dave is going to join me here or not. You're kind of frozen on my screen, Dave.
I'm back.
Okay.
I'm back. Can you see me, Jason?
I can see you now, yes.
Jason, that was really so cool. Thank you so much. Boy, the chat was going crazy with some of the experiments here. So a lot of people do some of these, which I think is really neat. And there's a million questions I'm trying to capture on. There's some really great questions. Okay. So I'm glad you're good on time. Let's spend some time on these questions. I saw one that kind of piqued my interest is when I look at your content. So by the way, somebody asked, is this a program you have to buy? And no, this is free content, right?
It's free content. Now, if you wanted to bring me to your school, that's a different story. And I have kind of evolved or went into this virtual program too. So starting the next school year, I will be offering 3 virtual programs, one about around energy, one around matter, structure of matter, and one around pushes and pulls, and of course weather. So there'll be 4. So that will come with a teacher guide, a student guide, so nonfiction reading. It will include a Zoom, so you and I sit down with your students via Zoom, science cards that are connected to NGSS, and enough material to do one science experiment with the kids for about 20 students, since I'm pretty sure we're going to start out the new year with small groups.
So so Jason, go to his site. It's a fantastic site. There's great resources there. It's easy to navigate. And by the way, Jason put together these activities that you showed today in a PDF. And we have those. We're going to send these out later. We'll make sure everybody gets them because they are amazing. It's beautiful material, really simple, colorful. I saw that. I like the coloring sheet at the end. That was a nice touch. That was really cool.
Kindergartners love that.
I bet. So we'll make sure everybody gets that. And I see people posting your website there. Jason, the materials, if you want to put it on your website too, people can go there. We're going to put it in the resources that go out. And we're going to put it on the Facebook group. And we would love to have you be a guest on that every once in a while and, pitch in. Because that'd be a great way to reach some teachers who are interested for ideas.
Yeah, and I'm focused in the Paducah, Kentucky area, but I do travel beyond that. I mean, once we start getting back to normal, I will be heading to a mall in Washington, D.C., one in Spokane. I'll be heading all over the United States I travel. So if I'm ever in an area to where, I'm already doing a mall event and it's already paid for, I can give you a big discount. I like to really help out schools, especially at-risk schools who need the hands-on science.
Jason, that is awesome. So I saw one intriguing question, the one that caught my interest. So your materials on your site generally are for like K-5 kind of level, but I saw somebody saying, you could use this for older kids, because I'll bet you even a high school student might have trouble explaining what is going on in the science, and give them a challenge, right?
Especially when it comes to RTI, a lot of, intervention whenever kids, maybe they didn't get the right amount of science that they needed for 7th, 8th, 9th, 10th, 11th, and 12th. And I do offer middle and high school programs. It's just I tailor design those around the teacher's needs. So if a teacher contacts me and says, Jason, I need a classroom program, you need to cover energy. Can you give me some ideas? And I'll say, how about this, this, this? We'll cover this. We'll do these experiments. He says, yes, no, we need this. So I hand design those middle and high school programs. But the majority of the free content, or all the free content that's free at hookedonscience.org, is mainly K-5, the videos and the experiment guides. Yes.
Yeah, and I think it's worth pointing out, you pretty much have the NGSS alignment on every activity sheet that I've seen.
Yes, and that's the goal. I don't try to make it hardcore, because I know teachers have sat through enough trainings to learn NGSS. What I try to do is show them the connection and to help and guide them connect an experiment to what they already know. That's the whole point overall. So yeah, I try to connect that experiment at the bottom right-hand corner of each one. I try to add the I can statements on there, so it's all connected in some form or fashion. That's the goal.
Great, great. Hey, I thought another interesting question. So the platforms you use for video, so we'll link those in the emails to go out. But it was a great question. A lot of schools have Google Classroom. They would be able to access that?
They should. Basically, I use something. It's my own little platform. It's through a place called JW Platform, and it enables me to create. It's a very phone friendly, because since I found out that so many families at home mainly have a phone, and that's how they're accessing all of this stuff virtually. They can easily link it off there, click on it, and it'll take them to it. It's like an app, if you will, if you choose to select that button, or you can just access it there. But you'll also find some of that same content at TeacherTube as well, and all of the, the national television appearances too, from Science with John Cena to Kelly Clarkson to the list goes on. All of that's all in one big spot. You just click on what you want to watch, everything from Science at Home to Sunday Night Science. So every Sunday night, at 7 o'clock Central Time, we do Science Live at my Facebook page, and then I post it on there.
Oh, is that right? Hey, we should link those on the Facebook group, because I people could just log in and check them out.
Yeah, and it's all free. So and I keep it simple, because what I have learned is that the majority of my viewers on TV at TV stations across America are females. They have 2 children. They're between the ages of 35 and 65. And they don't want hardcore science. They want something simple, flashy. They'll watch it for 30 seconds, and then that weekend they will try the experiment at home. They'll go to the website and get it and download it. Sometimes they include dad, sometimes they don't. But that's what my research showed, that they want it short and simple, to the point, learn something, and then we'll try it at home. So we'll go get the guide and learn more about it there.
I think you hit on a key point, Jason. Teachers, especially like K-5, they need something that they can do. You don't need an engineering degree to pull it off, right?
That's the key. That's huge, because the majority of K-5 teachers are not scientists. They teach everything from science to math to language arts, and most likely they're going to be required to focus on math, and they're going to be required to make sure every student in that classroom knows how to read. So I try to make my stuff simple enough to where if all day long they've been doing reading and math, because it's required and it makes sense, they can quickly integrate a Hooked on Science experiment within 30 minutes and wow the students and make it cool and easily understand it. There's nothing hardcore about it. It's short and simple on purpose.
Yeah, and I see it's kind of a repeat question. Your experiments are like K-5, but are they K-8 high school? You kind of target the K-5, but it looks you can scale this stuff really easily, right?
You can, and I've been getting more and more response for middle and high school. So, that experiment guide page where you're going to find it all will probably start to include more connections to middle and high school starting in the new school year 2021, because that has been a huge response. But, you know, of 100% of what I do, I would say 90% is K through 5. So that's why it started out with just K through 5 stuff. The rest is middle and high school. And with that, it includes everything from assemblies to classroom to classroom to, you know, the family science nights, which were very popular until COVID-19 hit.
Yeah, it's amazing. And somebody asked a great question too. Do you have biology related activities?
I've been trying to include that in. My main focus, my science degree is in meteorology, so more atmospheric science. So a lot of my stuff focuses on physical science when it comes to NGSS, because that's my expertise. But I do include some biology stuff, just a little bit. I would say 5% of what I do is on there. But if that teacher or any teacher ever emails me, and you can find my contact information at the website, and says, Jason, I'm really looking for something to teach this way. If I can't figure it out, then I will go to my mass list of educators and say, I have a teacher friend in Alabama who wants to know how to teach this concept. Do you have a suggestion? So I'll tap into my resources as well to help you out. So within a week, we'll figure out some way to teach the concept.
I could see why people are asking, Jason, my experience with you, your gift is taking things and making them simple and fun that anybody can understand them. And, you know, I think a lot of these concepts are hard, and having somebody like you tackle it, because it's a lot of work. You know, you make it look easy, but I know how much work goes into these things, right, to perfect them.
Yeah, it can be a lot of effort. I mean, you know, sometimes I'm up at 3 o'clock in the morning recording videos right in the studio right here, doing cool science stuff. You know, my kids are always helping me try them out. If they survive, then we'll do it in a classroom. Joking, no kids have ever been harmed. But yeah, it does take a lot of effort sometimes. But at the end of the day, it's not about me. It's about making sure every kid in America is exposed to science. And that's the goal. Whether COVID's not going to stand in my way, no one stands in my way of that. The goal is to make sure every kid in America at risk, to those GT kids, to RTI kids, everybody is exposed to science. And whatever it takes to do that, I'll do it.
You know, a couple of funny things. I see somebody saying, thank you for keeping science simple. So let me tell you, you and I had dinner once. I think it was in LA. We met for dinner.
Yes.
And I made the mistake of asking Jason, you know, a weather question. And I got a dissertation on atmospheric phenomena that was way over my head. This guy is really smart. And I don't know how you do it, but you take this really complicated stuff and you just make it easy for people.
Yeah, well, having 4 kids helps out. Let's just tell the truth. I mean, you know, if I didn't have 4 kids, I think it would be even more difficult on my end. But, you know, my kids range from, at this point, from ages 10 through 16. They're pretty close together. We're always doing science. And if I see them not getting it and I'm trying it on them, then I know I've got to change it. Because I have a mix of kids, you know. I mean, these 4 kids come from the same mom, the same dad. They're all different. They all have different strengths. And that's what's good, because every kid that's going to be accessing this information with mom and dad, or teachers, amazing teachers like you, are going to experience the same thing. Not every kid gets it the same way. So my goal is to attempt many different ways to make sure every kid gets something from it.
You know, you kind of hit a key thing. Kids learn differently, and especially science. I think, you know, we feel strongly that you have to get your hands dirty. You have to touch it. And, you know, simulations are great too, but they're I think, a supplement to get actually going out and doing something, right? And seeing what happens and trying to explain it.
Yeah, get dirty. You know, I've been in super squeaky clean classrooms where the teacher's like, don't move. And I'm like, there's no good science going on in this classroom. I'm sorry. That I've been in the classrooms to where there's a rat, well, not a rat, a guinea pig running around on the floor. And those kids are like, that teacher has the highest scores on standardized testing, and the kids just adore them. That's the key, to get a little dirty, to make a little mess every once in a while. It can be cleaned up, whatever it takes. It goes back to that. To get every kid in that classroom excited about science, I'm willing to do, and I know many amazing teachers out there are going to do the same thing. And, you know, when it comes to science, I'm a little concerned with COVID and the direction they're heading into, because next generation science standards is all about teaching kids science hands-on. And it's going to get really expensive if 2 kids can't share a science experiment and every single kid has to have their own ingredients. I mean, there's nothing we can do about it. but it's really concerning that, how many kids are we going to leave behind as we try to keep safe, try to stay well in this environment. So I'm hoping that parents and teachers can see that you can use everyday ingredients from around the house to do that, because I know their budgets aren't that big, and I know they're searching for, I don't want to say easy ways, but strategically thinking it out.
It's great that you're saying that. So what we've been seeing is that this kind of first phase of stay at home with the coronavirus, teachers are just trying to learn the tech, and learn how to do, you might have seen the end of Teacher Geek. They had like a live teacher experiment. They had a lot of technical issues, and that's how it is, right? That's just how it is. So,
well, a lot of teachers who have multiple classes today will tell you that first class is their guinea pig class.
Yeah.
I hope that all the students in that class are high learners, because that first class will be your experiment class, and then you will go from there and master it by 7th period, or probably before lunch. But no, you're exactly right. That's what teaching is all about. That's why I try to encourage many teachers to try it at home before they actually do it. Just so that they can master it before the class starts. And since my stuff, I don't want to say it's easy, but basic, that gives them that opportunity, because you just never know what's going to happen in the classroom. I do a lot of stuff on live TV, and I sometimes mess the whole thing up, because most of the time in a live TV setting, we only have 2 minutes and 30 seconds to do 5 experiments.
Yeah.
I'm about to do something in LA with a Fox station on Friday. And they told me I had 3 minutes to do 4 experiments via Zoom. So we'll do some cool science experiments and get it through and hope that all of them work. One time I had a pumpkin blow up on live TV because the anchor just kept talking. I'm like, hey, this thing's going to blow. We've got a lot of gas here. And then what happened? The whole pumpkin exploded.
That was going to be one of my questions. I've seen your TV demonstrations. I was going to ask you, did you ever set a set on fire?
I have, yes. That's why I always have a fire extinguisher, and we always focus on legally making sure everybody has the appropriate safety gear. I can tell a kid, you're not going to participate in this activity unless you wear safety gear, but I can't tell an adult that. I mean, it's their choice. Right. But as long as I have documentation that I told you to wear the safety gear, make sure that, you don't eat or drink your science experiment and so on, and it goes bad, and then everything's good. But we really try to push and focus on science safety at home overall.
Well, that would be a great blooper roll. I would love to see that.
You'll find it if you ever Google Jason Lindsey on YouTube. You'll find a lot of my interesting
Jason.
Yeah, just Google it. You'll find the exploding pumpkin out there. It happened about 5 years. It made it to every network, and every evening class used it as their kicker around Halloween. Kicker, you may not know what that means in TV words. A kicker is the last story we use in a newscast that's usually upbeat, funny at the very end of the newscast. We call that a kicker.
I'm going to Google that, and I think we're going to include it in the notes.
Yeah, you'll see it. And the whole thing explodes, and that specific talent did not want to wear goggles. And I said time and time again, please wear goggles. Yeah, she did after that. The next time I was on. But, sometimes I like pulling teeth.
Yeah, exactly. Jason, this is fantastic. Hey, one thought, I'm going to connect you with Paul Anderson. You guys are really complementary. You have really, I think you guys are doing a lot of similar things in different directions. And I think teachers love what both of you are doing in a similar way. It's making it approachable and easy. And so I'll connect you guys. You might find some synergy.
Yeah, well, I can tell you this, as I visit hundreds of classrooms across America, his name comes up a lot in those classrooms as teachers and I exchange resources. And I'm like, hey, I've tried this, another school tried this. Why don't you try this? Hey, Jason, I am having a difficult thing with my students understanding energy. We'll share resources, and a lot of times his content is brought up to me. So yeah, we're doing a lot of similar stuff.
Yeah, maybe next time we'll put you together and have a contest. We'll have like an Iron Chef. You get 3 materials.
Am I allowed to catch him on fire by accident?
I don't know. I don't know what the rules are.
Safe science. Yeah.
Hey, Jason, we really got to cut the break.
Okay.
Thank you so much. It's great to just chat with you virtually. I can't wait till we could see in person again. But thank you so much. You made a lot of teachers' days with this.
Yeah, just remember, teachers, we care about you. You're doing an awesome job. Hang in there. You're going to get through this. We're going to be stronger, and you're awesome.